Hi everyone, welcome to the first online lab demonstration for this course. This week we'll be going over the determination of pKa and the effects of substituents on acidity. Before we get into the experimental section, we're going to have a very brief pre-lab introduction by one of your TAs, Hannah Simpson.
Alright, so good morning everyone. Today we are going to be working on determination of pKa using a titration and the effects that substituents have on the acidity of this carboxylic acid proton. So typically you mix your carboxylic acid with your base, in this case sodium hydroxide, and you'll get your anion and water. Now the exact pH at which that proton is removed depends upon the nature of the acid. Today we're going to be looking at 6 different benzoic acid derivatives, and in your pre-lab you should have predicted what you think each one of these substituents is going to do to the pKa, and today we're going to see if your hypotheses were in fact correct. So for your raw data, you're going to get a curve something like this where you plot your volume of base, in this case sodium hydroxide, versus your pH. So you'll notice your curve gradually increases until it has a steep jump and then levels off. This halfway point in that jump, that is called the equivalence point. That is when all of your acid has been converted into its conjugate base and your titration is complete. If you look at that, the volume of your base added for your equivalence point, to determine the pKa, you take half of the volume you added to get to your equivalence point, and then take the pH at that point along your curve. That will in fact be your pKa for this week. However, we want to make sure you do it a little bit more exactly than just doing that. So out of lab, you will be responsible for completing 2 plots. A first derivative plot, shown here, at which point your equivalence point is the peak of this curve, and a second derivative plot, in which case your equivalence point is going to be the x-intercept here. Both of those are going to be volume of NaOH that you can easily calculate and then go back and extrapolate along your original data to determine your pKa. Once you have your pKa, it is up to you to compare that with your hypotheses as well as the pKa's determined by other people in your section and see, were you correct and how accurate were your calculations?
Alright, just a quick reminder that when you're watching this video, please make sure to take observations down. Usually we would have you take down a table of the sodium hydroxide volumes that you were added, but for this experiment that's not going to be required. Okay, so now we're going to show you what the different carboxylic acids look like so you guys can get a sense of what they are. Here's nicotinic acid, 4-nitrobenzoic acid, fluorobenzoic acid, and 4-dimethylaminobenzoic acid. So for the lab demonstration that we're showing here, we're actually not going to do all the amino acids. We're only going to show one of them, and it's going to be benzoic acid. Okay, so here we are weighing out the benzoic acid. We want to get as close to 20 milligrams as possible. I realize that it's not the easiest thing to see what the benzoic acid looks like, so you should note that it's a white solid. Okay, and we got about 19.5 milligrams, so that's close enough. We're going to add it to our beaker. Next, we just get 25 milliliters of methanol. We want to add methanol first because we want the carboxylic acid to completely dissolve.
More like 26, but...
So we'll add the methanol to our solid and try to get it as dissolved as possible. Okay, we'll let that stir for a bit. And now we take the 25 milliliters of water so that we can dilute it. And we need to have water so that we can more accurately measure the pHs. So a mixture of methanol and water is good for that. So we'll get about 25 milliliters of water as well.
Yeah, that's good. Cool.
And then we'll get a close-up of the solution. So it should be a little bit cloudy at the beginning, and hopefully over time it'll completely dissolve. Okay, so while we're waiting for a solid to dissolve, we're going to set up the pH probe. So the pH probe is really sensitive, so you want to wash it with only DI water. And when you dry it, you need to use a Kim wipe so it doesn't get damaged. So now that we've cleaned the probe, we're going to standardize it. And to do that, we'll use two different standard solutions of pH. So one of them is at pH 4, and the other one is at pH 7. So we just set up the lab quest, and once we put it into one of the solutions, we tell it what the pH reading should be. And then you put it in the second solution, and then tell it what the second reading should be. But in between the two standards, you want to make sure to wash the pH probe carefully, again using DI water and a Kim wipe. So now we're putting it in the pH 7 solution, and then usually just having 2 points is good enough so that you can calibrate the pH probe. Okay, so now we're going to set up the titration. But before that, it's important to note the actual concentration of the sodium hydroxide solution that we'll be using. So you get your burette, and the first thing you do is you just add a little bit of the sodium hydroxide solution, just enough to wash it down. And then after you've already drained the first solution, now you want to fill it all the way up to the top. And we want to get as close to that 0 mark as possible, that way it'll make all our calculations simple. And this is the setup. We want to get the pH probe all the way inside the solution, and then we want to clamp the burette so that we can easily dispense the sodium hydroxide. So we'll start out by adding half a ml at a time. And each time that you dispense the sodium hydroxide, you just take down the pH reading. So we keep repeating this, adding half a ml at a time.
Good luck.
Yeah, thank you.
So for a while, there's not really much change in the pH when you're adding half a ml at a time. So we're just going to skip ahead and show you guys what it looks like for the first half of this experiment. So if you notice on this table, we've added all the way up to 10.5 milliliters, and the pH has gone up very gradually. I'll plot it for you guys so you guys can get a better sense of what it looks like. So here's what it looks like on a plot. So then I'll show you guys once we go up to 11 milliliters. So once we add 11 milliliters, you'll notice that the pH will start to go up more rapidly. So it actually takes a little while for the pH to stabilize, and that's good because that tells you that we're right at the end point of the titration. So this would be the equivalence point. So when we add this last data point to the table, you can see that there was a big pH change with the last half milliliter. And then on the graph, you can see that the slope now increases. And that's really all we needed to do for this quick run. But just to make sure that we have reached the equivalence point, we're going to run a couple more points. And I'll just show them on the graph now. So you can see that we definitely reached the equivalence point, and now we're tapering off. So the quick run gave us a pretty good estimate of the equivalence point. So now we're going to do the slow run. For that, we weighed out 21 or 20.1 megs of benzoic acid. And we're going to do the same thing as last time. So we added the benzoic acid to this flask, and then added 25 milliliters of ethanol. Let that start stirring for a little bit. Then we add 25 milliliters of water. And then once again, we want to get all of the solid dissolved before we start the actual pH measurements. It's really important again to clean off the pH electrode in between each run. So we'll wash it with DI water. And then we'll get a Kim wipe to dry it down. So notice that we didn't have to refill the burette for the second trial. Since we know at the point where we're starting, we can use that to calculate the amount of volume that we're adding each time. And also for this second slow trial, we're actually adding about 1 mil at a time. The reason for that is because when we did the quick run, we got a good idea of where the equivalence point was going to be, so we can start adding 1 mil at a time until we get close to the equivalence point. And then once we actually get close to the equivalence point, then we're going to add really carefully. So once again, I'm going to jump ahead and show you guys what it looks like after we've added a few milliliters. So here's what the table looks like so far. Like I said, we were adding 1 mil at a time, and there's not really much of a change in the pH. It's going very steadily. And then once we add 10 milliliters, then we're going to start adding 1 to 2 dropwise. So we're adding 2 drops right now and checking the pH, waiting for it to stabilize. And then we add another 2 drops at a time. Check the pH again, wait for it to stabilize. And so here you can see what it looks like after we've added a total of 1 mil, 2 drops at a time. And you can see that we got a lot more points on this equivalence point curve. And then just to make sure again that we passed the equivalence point, we took a few more time points, and you can see that the curve is flattening out at the top. And that completes the lab demonstration for this week. Just a reminder, when you're doing your final lab reports, the data that you'll be using for those is actually the one that's provided on Blackboard. So there's 6 different carboxylic acids, and we provided data for all of those. You only need to do it for one of those. And in order to determine which one you are assigned, please look at the spreadsheet on Blackboard. Thank you.